Okay, so we know how to solve by factoring now, but that's not always going to be the best way to find our solutions. Let's say we have a problem that looks like this. X squared minus 48 equals 0. Well, if I start trying to factor this and use the box method and all of that, it'll probably work out, but it might not. And instead of going through all that hassle just to figure out that it won't factor, let's try a different way. Whenever it's possible, if you don't have a middle term, we want to try to get x by itself instead of trying to get everything onto the same side. Let me show you what I mean. Let's do x squared. In order to get minus 48 from the left side to the right side, I need to add it to both sides. So x squared equals 48. Okay, so now it looks like I've got an x squared over here all by itself equals 48, but I'm not really worried about what x squared equals. I want to know what just x equals. So I have to cancel out that squared. Now just like when I have a minus, I need a plus on both sides, I need to know what the opposite of squared is. The opposite of squaring is to take the square root. So that's what I'm going to do. I'm going to take the square root of both sides here. The square root of x squared equals the square root of 48. So the square root of x squared, well, the square root and the squared cancel out just like I wanted them to. So I get x equals the square root of 48. Now that I've got the square root of 48 here, I can simplify it. Now, one nice thing about a lot of calculators is that they'll simplify it for you. But if you don't know how to simplify it in your calculator, or if you don't know how to simplify it by hand, you're going to have a lot of trouble really understanding what's going on here. You kind of have to rely too much on your calculator. So let's take a look at what's really going on. In order to simplify a radical, what we want to do is try to break it up into factors of the number inside the radical, where one of them is a perfect square. So if I think about some of the factors of 48, well, I can do 24 times 2, but neither one of those is a perfect square. Let's see, I can do 4 times 12. So 4 is a perfect square, but let's see if there are any others. Some other factors of 48. How about 16 and 3? Ooh, 16 and 4 are both perfect squares, so how do I choose which one of these? Well, the trick here is to always take the perfect square that's larger, because that means that you have to do less simplification later on down the line. So I'm going to rewrite this. X equals the square root of 16 times the square root of 3. Now I can only simplify one of these. Which one is it? Take a second to think about it. It's the one that has a perfect square. So if I take the square root of 16, that's 4. I've got x equals 4 times the square root of 3. So here's one thing that we've got to remember when we take the square root sign, though, is that we need a plus or minus. So even back to here, plus or minus, plus or minus, plus or minus. It might seem odd that I'm saying that both the positive square root of 16 times the square root of 3 and the negative square root of 16 times the square root of 3 is equal to square root of 48. But if you think about whenever we square a number, if I take 1 times 1, it's equal to 1. So we could say, oh, the square root of 1 is just 1. But negative 1 times negative 1 is also equal to 1. So that means that the square root of 1 is equal to both positive 1 and negative 1. That's why the plus or minus is in down here. All right, so let's see if we can use that whenever our quadratic is in vertex form. So something that looks like this. Let's do x plus 1 squared minus 2 equals 0. So again, here, our first instinct might be to try and FOIL this out and then use the factoring method that we learned before. But that might not always work, and it's going to be a lot of work just to figure out it won't work. So instead, let's try a different approach. Let's use the same idea that we did before and try to get x by itself. The first thing we have to do here is to add 2 to both sides. We always need to do the addition or subtraction before we take care of the exponential there, or the exponent. So here we've got x plus 1 squared equals 2. Alright, so I've got x plus 1 squared equals 2. I need to cancel out this squared, so again, remember that the square root is the opposite of squaring something. So if I take the square root of both sides, I get x plus 1 equals the square root of 2. Now, the square root of 2, if you put it into your calculator, it's just going to tell you the square root of 2 again, unless it gives you a rounded decimal. It can't be simplified. And remember, we've got a plus or a minus here because we took the square root. Now what we need to do, our last step to get x by itself, is to subtract 1 from each side. Minus 1, minus 1. So I have x equals negative 1 plus or minus the square root of 2. So this is actually two different answers. This is x equals negative 1 plus the square root of 2, and x also equals negative 1 minus the square root of 2. Okay, it's important that we show both answers. If you only have a plus here, you're really only answering half of the question. It's a quadratic, so it's always going to have two answers. Sometimes it's the same answer twice, but it's always going to have two. Alright, so these are our two answers. We can't simplify these any. You can think about this the same way as trying to combine a negative 1 with a negative x. So we couldn't say negative 1 minus x, and we couldn't simplify that to anything else. That's the same idea here. This negative 1 can't be combined with the square root of 2. We have something inside of a radical and something not inside of a radical. So our final answer is just exactly what we see here. Negative 1 plus 2 and negative 1 minus 2.